Hey, this is Mr. Mitchell with a video about organizing the elements on the periodic table. Now, you've seen the periodic table. We have the periodic table in our classroom. It's on page 500 of the textbook. How do they get that organization? And it actually has a lot to do with these subatomic particles that we have learned about. It has a lot to do with the positive protons. You may remember the protons are in the nucleus, along with the neutrons that don't have a charge, and that is the main mass of an atom. And then you have these electrons which have a negative charge, but they don't really carry much mass. Now, kind of a side note on the electrons that I did not mention before. Scientists think the electrons are going so fast that you can't really see individual particles like you can on this first model here. They liken it to an electron cloud. And if you think of a fan or bicycle spokes, whenever a fan is on or when somebody's on a bicycle, you can't see the individual blades or the individual spokes. They just kind of go around in a big whir. So that's kind of what scientists are happening in this electron cloud, that you can't really see the electrons. But they do think that there are different levels of electron shells, is what they call it. So here outside of this particular atom with the protons and neutrons in the center, you have this first electron shell which can only hold 2 electrons. Then you have another electron shell which can only hold 8, and another which can only hold 8, and so on and so on. The first one holds 2, and the ones after that hold 8. And that determines how the elements react to each other. So what happened was, and I have up here the 12 smallest elements from hydrogen to magnesium. These are the 12 smallest elements. What people noticed was that helium hardly ever had a compound with any other element. And that was the same thing true with neon. However, helium had 2 protons and neon had 10 protons. But they did notice that something like hydrogen, it interacted a lot, even though it was just 1 proton away from helium. Hydrogen has 1 proton, helium has 2. They also noticed that lithium acted a lot like hydrogen did, that it interacted with a lot of stuff. So the reason they interact with a lot of stuff is their outer electron shells are not full. If we go back to this, we were talking about the outer electron shells. If they have 8, or if they have 2 in the first case, then they're not going to want to react with anything else. So when you have hydrogen, it has that 1, it still wants to connect with other elements. So the ones that have the full shells are like the helium and the neon that hardly ever interact with each other. So that's how these ended up being put together, because of what was in the outer shell. And I'm kind of reconstructing what we have here. But we have in the outer shell, we have lithium has 1, beryllium has 2, boron has 3, carbon has 4, nitrogen has 5, oxygen has 6, fluorine has 7, and then you have neon, which has 8 in its outer shell. So that's how these ended up getting put in the situation that they are on the periodic table. Now, sodium here, it interacts a lot. It only has 1 in its outer shell. And magnesium has 2 in its outer shell, which still interacts a pretty good bit. So that's how the first part of the periodic table got to be. So looking at it again, you can see some things like hydrogen has the 1 proton and the 1 electron that is around it. It does not have its shell filled up. If it had its shell filled up, it would look like this, like helium. This is helium, has 2 in its outer shell. Here we have neon, which has 2 in its first shell. but it also has a complete 8 in its second shell. Argon here has a complete 2, then a complete 8, and then another complete 8 outside right here. So you have sodium, which is all complete except its outer shell has just 1. So you kind of see what patterns are happening. Here I think we have carbon. Its outer shell has 1, 2, 3, 4. So it wouldn't be as interactive, but it could still interact with other atoms. So that's kind of the basis as to how these got put on the periodic table as they have. Now we're going to end up doing something called dot structures, and you can take any element and put dots around it that represent how many electrons are in its outer shell. So you can see which ones are like neon and which ones are like helium that have a complete outer shell and which ones do not, and you can actually match them up. Well, I hope you learned a little bit about the organization of the elements on the periodic table.